In this video, I'm going to show you guys how to take a parent function. In this case, I'm going to graph f of x equaling x cubed, so the parent cubic function. And we're going to translate this function 6 units to the left, and then we'll use GeoGebra to graph that as well. So in GeoGebra, I have an input column here, and I just happen to make -10 to 10. All right, so we want to evaluate our function x cubed with these specific input values from -10 to 10. So to do, I'm going to click on the cell B1, and this B column will be my output column. But I'm going to create a little formula. I'm going to say this cell is going to equal and then we're going to evaluate our inputs cubed. So I'm going to say that this is going to equal A1, that number, -10 cubed. So I'll just raise it to the third power. So -10 times -10 times -10 is what we're going to get out, which is going to be a -1000. Okay, so I know that that number is right. I'm going to take this cell and I'm going to drag the pattern down, and there are all my cubed input values from -10 to 10. So these are the input-output values for our parent function. So to graph the parent function here, I'm just going to highlight all my data. I'm going to come over here and I'm going to grab the Create List of Points tool. I'm going to make sure that -10, -1000, -9, -729, those are correct. So I'm going to hit Create. And now here's our cubic function. So if I zoom, or if I change my axis, we can kind of see some of the data, right? So here's our points. If I skew it, some of those numbers, when you cube it, get pretty big pretty quick. So this is our graph here. And to check, to make sure we did this right, I'm just going to put x cubed in the input bar. We can hit enter, and notice it goes through all of our points. So there's our parent function. Now we want to graph this thing translated 6 units to the left. So basically, what we want is all the points, like this one, for instance. If this point is sitting in an input of 3, then if I translate 6 units to the left, we're really going to take 3 minus 6. I'm going to subtract 6 from the x value that it's sitting at. So 3 minus 6, if I go back 6, 1, 2, 3, 4, 5, 6, I end up here at -3. So this point is going to translate 6 units to the left and end up at the same y value. It's just the x value is going to get 6 subtracted from it. And all of these points are going to go 6 units to the left. So it's going to take the whole curve, and every point is going to get translated 6 units to the left, which ultimately translates the whole graph 6 units to the left. Okay, so what we need to do, since translating horizontally, or this way, right? This is our input axis. So when we translate horizontally, it's going to actually affect the input values that we're putting into our function. Okay, so the idea here is that I'm going to take these inputs and I'm going to subtract 6 to them, and then I'm going to pair the new subtracted inputs with the corresponding output. So if I take -10 and I subtract 6 from it, I get to -16. So it's like an x value now at -16, but we're still going to get out -1000. Right? If I take, say, this point -2 and I subtract 6 from it, I'm going to end up at -8, but I'm still going to get out -8, right? If I take 0 and subtract 6, I'm at -6 for an input, but I still want to get out as 0. Okay, so to do that, there's a couple ways we can do it. Right now, I'm going to show you how to, let's just fill in this empty column C by taking our inputs and subtracting 6 from them. So I'm just going to say that this cell is going to equal whatever value is in the A1 cell minus 6. So there's our -16, and I'm going to go ahead and continue that pattern for all of our inputs. Okay, so now we just need to create some points. We have our new inputs where we subtracted 6 from the original parent inputs, and we want to pair it with the same output value, right? So what we're going to do is highlight our 2 input-output columns. Now typically, you got to be careful with this because when the left column is usually going to be the input column, and then the right column, the second one, is going to be the output column. But the way that we have this set up right now, it's actually backwards. C is our inputs, B is our outputs. So when we go to create our list of points, we're going to click on that tool, and it gives us our preview window. Notice right now our input of -1000, output of -16, and that's actually backwards. So this little box right here where it says X then Y, we can actually change the order, and I'll say Y then X. So now we know that if we put in a -16, we get out -1000, and that's exactly what we wanted to get. So I'm going to hit create, and there's my points now that popped up over here, 6 units shifted to the left. Okay, now when you're going to write the expression for this curve now, that's going to go through all of our new translated points. So remember that our parent function, f of x, is equal to x cubed. Now, in the previous video, if we add or subtracted a value to these outputs right here, like if I added, say, 6 or subtracted 6, we're actually adding or subtracting two output values, which the output axis is our y-axis. So if we add or subtract to that, it's going to move the graph up or down. So we don't want to do this. We actually want to affect the input, right? So maybe we might think, okay, well, I'll take my x value that I put into my parent function and subtract 6 to it, right? Because that's what we did to our actual points. And if we do that, if I put in parentheses x minus 6, take an input, subtract 6 from it, and then cube it. Okay, and we hit enter. Ooh, weird, this little graph over here popped up, right? So, ooh, the -6, this looks like it shifted 6 units horizontally, but it went to the right, it went to the wrong direction. So if we're thinking opposite, I want to go opposite direction. Maybe instead of subtracting 6, I'm just going to change my function here, and I'm going to add 6. Ooh, look at that. So my graph now has changed. I just changed that function, and now the graph actually went 6 units to the left when we added 6 to our outputs. So really, x plus 6 cubed is, which is right here, is the actual function that moves points 6 units to the left, which is kind of weird because we subtracted 6 to the x coordinates and made the points move 6 units to the left because we took whatever x value, subtracted 6. Like if I took this x value of 1 and I subtract 6 to it, that point now moved over here to -5, keeps the same output, right? But what we have to think about when it's the formula, this new point that just translated over here to -5, it needs to have the same output as a point that's on my parent function. Okay, so what that means is I need to take this -5 value. Oops, I don't know why that happened. Weird. I'm just going to delete my pen stroke there. I need to take this -5 value. So again, our formula, or our expression, is really this x, plus 6 cubed. So what that means is if I put in my new x value for my new function, I need it to have the same output as this point that got translated 6 units to the left, right? So what I need to do to my input of -5 is I actually need to get back to where I started, and then if I get back to 1 and cube it, then I can get my output of 1 again. I hope that makes sense. So like this point here at -3, I need to get the same output as its translated point, which is here. So to get back to it, I need to undo my translation of 6 to the left by adding back that 6 that we subtracted off to fill out this C column. So actually when we write equations that translate horizontally, we're going to take our input, we're actually going to add the opposite to it as the translation does, so that we can go back to an input that gives us the same output value. So I hope that that kind of makes sense, and we can clear that up in class a little bit too. But that is how we can graph functions and points translated horizontally, and then when we write the equation, it's kind of an undoing thought when we do that. Okay? Thanks, guys.